Hello, I'm Kristjan and I will present Materials Cloud. So first I want to give an overview on our open science platform, which consists of three parts: AiiDA, the main topic of this tutorial; Materials Cloud, that I will talk about, that this presentation is about; and AiiDA Lab. So to give context on how these three parts relate to each other and which problems they solve, I want to illustrate four different challenges of computational materials science. So the first is running high throughput calculations. You have to organize a large number of calculations. You have to deal with corner cases. There's many strings to pull, and everything has to work in an automatic way. And this is what is solved by AiiDA. Second challenge is reproducibility. Keep track of what you calculated, how you calculated, and how this could be reproduced. For example, let's say a postdoc Alice wants to reproduce what Bob did 1 year ago, or this could also apply to yourself, what you did in the past, or to a collaborator from a different group. So again, AiiDA solves this challenge. Third challenge is open data. So how to publish data in computational material science, and especially relevant to high throughput calculations. There can be many different files, a lot of different data. So adding this data to supporting information as a PDF is not really feasible or effective way to share your data. Uploading all the files and all your data is also not effective. It's very hard to relate different parts of the data to each other. So what is effective is this FAIR data standard, which is findable, accessible, interoperable, and reusable data that Materials Cloud, together with AiiDA, strives to provide. And the last challenge is knowledge transfer. So how to share a workflow with a collaborator, how to share the environment, how to share live results of simulations, and this is what AiiDA Lab is providing. There will be a separate talk on AiiDA Lab in this tutorial. So this presentation is focusing on Materials Cloud. So Materials Cloud consists of 5 different sections: Learn, Work, Discover, Explore, and Archive. And before I delve into each of these sections, I want to make an analogy with Git and GitHub. So think of AiiDA as the engine. So you would use AiiDA on your local machine to run many calculations. You will have all of the data and all of the provenance on your local machine, similar to a Git, where the source code is on your local machine. And then Materials Cloud is the dissemination platform, like GitHub. So a platform where you upload your data, you, let's say, push your data so that others can pull it, or others can download it and use your data, and potentially also add to your data. So this is what these 3, Discover, Explore, Archive, these sections provide, but Materials Cloud is more. So there's also Learn and Work. So now I will give, or before I give a detailed overview of each section, I just want to mention there is this paper, Materials Cloud paper, published in Scientific Data 2 years ago. So if you want more details on Materials Cloud, you should read this paper. So let's go through the sections, the 5 different sections, and starting with Learn. So the Learn section contains videos, different sections to many different videos, where you can learn about computational materials science from experts in the field. So what you can do in the Learn section: you can freely access videos, lectures, tutorials. You can learn new theory, new methods, new codes. Next section is Work. So this is for data generation. So this contains multiple parts. So the first I want to showcase is Quantum Mobile, which is a downloadable VirtualBox virtual machine image. with pre-installed AiiDA environment and codes like Quantum Espresso Yambo. It's ideal for education, like courses or tutorials. Also, there's a cloud version of Quantum Mobile. Second part of the cloud section, or the work section, is AiiDA Lab. It's a web platform of web applications for running AiiDA workflows. You can access through your web browser. Apps are based on Jupyter notebooks, and they're published in an app store. So you can, in your AiiDA Lab environment, you can go through the app store and install the apps that you like or need to run your workflows. It's built with Jupyter App, Docker Spawner, or Kubernetes. And as I said before, there will be a separate talk on AiiDA Lab. And then the third part of the work section is tools. This contains web-based applications that you can run directly in your browser. So for interactive visualization and fast data processing that should complete within a few seconds. And I want to showcase two of these tools. So the first is seekpath. So here is a list of different tools. You can, we click on the seekpath tool. So this is to calculate the band structure paths in reciprocal space. Here is for a face-centered cubic, relevant zone, the crystal structure. It will identify high symmetry points in the brilliant zone and suggest the path. And you will get the input files to different codes for the band structure calculation. The second tool I'm going to showcase is phonon visualizer. So here you can kind of upload your phonon calculation, and you can visualize the phonon modes of the phonon band structure of different phonon bands. To summarize the work section, what you can do, you can run your own simulations on your computer using Quantum Mobile, on the cloud using AiiDA Lab, or you can access pre-processing, post-processing, and visualization tools in this tools section. Now I want to present how Materials Cloud facilitates fair data sharing. So these three sections: archive, discover, explore, and I want to start with the archive section. So in the archive section, researchers can upload their research data, and here is an entry for one uploaded data. And what it contains is the title, some description, and then the files that have been uploaded. So the archive section provides a DOI on your dataset. It's indexed by Google Dataset, Fair Sharing, and other websites, so it's easily findable. It's recommended by Science or by Nature Scientific Data and Open Research Europe journals. There's also GoFair Implementation Network. So anybody who's doing computational materials science or also experimental science can upload their data here. But if you have performed your calculations with AiiDA, you can also add links to discover and explore sections. And to demonstrate this, I'm demonstrating this for this entry, the two-dimensional materials database entry. I will showcase the discover and explore section to really make this data easily accessible. So here is the discover section. So discover section is a curated data. So the researchers have developed an interface to access their data. So here, for example, for the two-dimensional database, there is a different page for each compound. So this is for magnesium bromide. And you will get different kind of properties calculated for this material, and for example also the band structure. So you can explore the material, explore the properties in a curated way. And what's interesting is that you will have, for different properties, you will have this AiiDA link that links to the explore section where you can browse the provenance. So here I will just showcase, you click on, for example, the band structure, and this will jump to the explore section where you can explore how this calculation was performed. So the band's calculation is one node, and you will see what generated this node, where this node was used also. So this calculation now generated the band structure node, and you can see the input script of the calculation, the output log of this calculation. So this was a quantum espresso band structure calculation. You can also see different inputs to this calculation in the provenance browser. So for example, this is the structure, input structure of this band calculation, and you can download, for example, the structure, and you can see other inputs and also outputs of in the graph explorer. So this is the kind of explore section. So the explore section is to explore the raw data and how the data was obtained, and discover is to visualize in a curated way the data. So what you can do, you can access hundreds of different data sets in the archive section and reproduce their research. And you can also contribute and share. So you can freely upload your data to the archive with or without AiiDA. You can get a DOI with availability guarantee of 10 plus years, and you can make a research easily reproducible, share your curated results, and make your AiiDA graphs easy to browse. And now I want to kind of illustrate how the combination of AiiDA and Materials Cloud facilitates fair, compliant data sharing. So it's findable, the data is findable because you have DOIs with standardized metadata. It's accessible, web interface to browse data calculations and provenance, curated in the Discover section, interoperable, so you have data linked via the AiiDA directed graph, can easily be imported into your own AiiDA environment, so you can directly use the data in your own calculations, and it's reusable, so you can download the data. We encourage open licenses, and it's fully reproducible thanks to AiiDA. And what we also provide on Materials Cloud is data management plans or data management plan templates for researchers who are using Materials Cloud. So both for researchers who use AiiDA or who are not using AiiDA, at the moment for two different funding bodies, so Swiss National Foundation and this H2020. So you can just download the template and you can use it in your research. What you can do, you can use AiiDA and Materials Cloud to make a research fair, so your research data fair, get a data management plan template to easily prepare your grant applications. So here are some frequently asked questions about the archive. How much data can I upload per record? So by default, everyone, if you're not using AiiDA database, then it's 5 gigabytes. If you're using AiiDA, it's 50 gigabytes. How long will the data be stored? Guaranteed at least 10 years after submission. Can I update the content of my record? Yes, but only references or keywords. If you want to, let's say, update the data or description, you should create a new version. So how to make a new version? Edit existing submission and request publication again. So when the new version is published, the different versions will all be listed under your entry. Can I reserve a DOI before publication? Yes. And here at this URL you will find all of these policies. So before I conclude, I want to also give an overview of the technical details of the Materials Cloud platform. The front end on the left hand side is mainly running on AngularJS framework. So the users access the front end with their browser. AiiDA users can use the AiiDA REST API to connect their AiiDA database to the Explore section. So these machines are running on virtual machines using OpenStack deployed at CSCS. We're using for the backend data, we're using block storage Cinder, long-term storage Swift, and the backend uses a couple of different technologies. So the Learn uses Slideshot, Archive uses Invenio, and AiiDA Lab, Discover, and Explore are all built on top of AiiDA. So using AiiDA REST API, and then AiiDA, of course, for the, let's say, the AiiDA Lab is communicating with HPC centers. So some future plans for Materials Cloud. So we really want to improve our 3D and 2D crystals databases, so MC3D and MC2D. They're accessible now, but we want to expand the database and add different ways to visualize and process the data. Of course, continued support and improvements of the archive, especially tighter integration with Discover and Explore sections and the AiiDA Lab. And related to this is we really want to automate the creation of Explore sections for submitted AiiDA databases. So if you upload AiiDA database to archive, at the moment, to generate an Explore section, we have to implement this. But if this was automated, it would really speed up kind of the data, making data easily accessible and available. And when this is done, so this could be done in a way similar to Git and GitHub, like within like a push and pull mechanism. So before I conclude, I want to acknowledge the funding agencies. The main one is Marvel and CCR, Max Center of Excellence, Marketplace Intersect, Swiss Universities, OSCAR, and PSI. Thanks a lot for your attention, and I hope you have fun exploring Materials Cloud.